Okay, our goal is to tell me if this is a function, yes or no. Then I'm going to write the domain, and then I'm going to write the range. Okay? So to do this, if you saw the video, it's fairly simple. Okay? In the video, they talk about the input. All right, so this guy, these numbers, this set of numbers, it has a multiple names. It's called your input. We also can call it our domain. It's also our x values. Okay, when we're graphing, these are our x values. And if you remember, this is also the independent variable. So all these names just mean input. Okay? This set over here is your output. It's also called the range. These are usually your y values. And it's a dependent variable. Okay? So in other words, these numbers depend on these numbers. All right? In the video, if you saw, they use the supermarket analogy, like if you're going to the store. All right? And it's very simple to understand. So let's imagine that these numbers represent items at the store. So we have item 14 at the store. So you're at, I don't know, Stater Brothers or Ralph's. Okay? And you go, you know what? I want to buy item 14. Okay? These numbers represent the price of that item. So item 14 has a price of 0. Okay? And what makes it a function is every item that you have, every input or item that you have at the store should only have one price. If an item has two different prices, then it is not a function. Okay? So all we're going to do is check, do my items have their own price? So let's check 14. 14 has its own price of 0. Item negative 25 has a price of negative 1, its own price. Okay? Item 24 has its own price of 5. And then item 33 has its own price of 0. So all these items, they are all different items at the store, and they have their own individual price. Okay? I know 14 and 33 have the same price, but that's okay. There's going to be times where you go to the store and you have different items, but they're exactly the same price. Okay? And that's all right. That's still okay. So based on this idea of here are the items at the store, here's their price, because they all have one and one price only, that means this guy is a function. Okay, so he is a function that he only has, the items only have one price. The domain is now, all we're going to do is simply list the items in the domain. Okay, and we're going to use a little squiggly bracket. So the items are 14, negative 25, 24, and 33. And then we're going to close it with the squiggly bracket. The range is the same idea. We just write the prices of the items. So we have negative 1, 0, and then we're not going to write negative 1 again because we don't repeat our domain and range. So we already have negative 1 listed. We don't have to write it again. And then the last one is 5. Okay? And that's domain and range. All right, so that's basically how you're going to do this. Let's jump over to number 2. I'm not going to do the whole entire thing. I just want to make sure you understand about when it's a function and when it's not a function. So if you look, here are my items at the store. Here are their prices. So the item of negative 2 has a negative 1 price. That's good. But here's where we get a problem. The item of 0 has 2 different prices. So imagine going to the store and you found, I don't know, a pair of jeans. And then they go scan it at the register and they're like, you could pay either negative $1 or you could pay $1. Which one do you want? Okay? So that store idea of an item having 2 prices doesn't make sense. It cannot have 2 prices. So that means this is not a function because this item here has two separate prices. So we would say no function. And because it's not a function, we don't have to put the domain and the range. Number 3, just really quickly, I'm not going to do this, but if you look, do all my items have an individual price? And the answer is yes. These are all different items. They just so happen to be the same price. So this would be a function, yes, because they all have their own price. Item number 10 only has one price. Item number 20 only has one price. 30 has one price. 40 has one price. 50 only has one price. They just so happen to have one price. Okay? Think of this as the dollar store. All different items, but they only have one price. So this is a function. That is good. Okay? The problem arises is when you have one item that has two different prices. That's when it's not a function. Let's jump to number 4. Okay, this is just a different way. Right here, we were mapping the functions. This is called mapping. Now we have ordered pairs or points. So what you have to just understand, and if you saw the video, they explained this. The first number is, if you recall, is your X, and the second number is your Y. But if you're talking about domain and range, this is your domain, this is your range, or this is your input, this is your output. Just like I mentioned here. This is your X numbers, this is your Y numbers. These are now just arranged in point format. So again, the 4 is your X, the 2 is your Y, this is your domain, this is your range, input, output. And you could do that for all of them. Okay? So what we're going to check is, does my inputs, do my items at the store have only one partner, only one price? So let's look. So item number 2, my input, what's its price? It's 2. Okay? So item number 2 has 2. We're good. Item number 4 has a price of 2. That's okay too. It's a different item, but it's the same price. That's all right. Item number 5 has a price of 2. He has its own price. It's only one price. But then if you go here, if you notice, item number 2 again. Here's item number 2. Here's item number 2. So it's the same item, the same input. Does it have a different price? So if you look, item number 2 here had a price of $2, let's just say. Item number 2 here, which is the same item, also has a price of $2. So in essence, it basically saying item number 2 has the same price. So this is still okay because it didn't change prices. It's just a repeated point. And that's okay. It's a repeated point. It has the same price. Item number 6 has its own price. We're good. So we would say, yes, this is a function. Okay. The domain, we will list all the X values. So it's 2, 4, 5. Okay. And then we have 2 again, but we already have it, so we're not going to write it. And then we have 6. And then the range is going to be all the Y values. And if you notice, they all have the same Y value. It's just the number 2. They all have the output of 2. Okay? Cool. So this one's more of a concrete problem, number 5. It says, is this a function? The license plate numbers to cars in a state. So think of it this way. This is my input. All license plates. Okay. My output is all license plates in a state. So like California. All right. So from all the license plates in the United States, Okay, so if you can imagine, there's just a bunch of license plate numbers here. Some of these license plates here belong to California. Some are in New York, some are Texas, some are Arizona, some are Alaska, some are Arkansas. But again, there's some California plates in here as well, because it includes all the states. So all the California plates, so if I pick a license plate from the input, will it match a license plate from California? Okay? Or would it have two different license plates in California? So this kind of takes some logical thinking. So if you had all the license plates in the world, or in the United States, and you had, let's just say we had license plate B, let's just use one number. Would license plate B be used by two cars in California? Yes or no? Okay? That's how you think about it. So if you think about it, I don't know about you, but if you notice license plates, they don't repeat. It's one license plate per car. So that means one license plate only exists. If the license plate is B, it only has one license plate in California. It will not have a second car having the same license plate. Okay? So because of that, one license plate here will only belong to one license plate in California. That means this is a function. It's 1 for 1. The domain would just be all license plates. That's what I wrote down. Okay, and the range would be state license plates. All right, so I just want to show you that one because that one is somewhat confusing, but not too bad. You have some other ones in your assignment. All right, let's check out this one. So we now have a function, okay? And we want to figure out this is a function. So the best way to figure this out is we are going to plug in a number for x. We get to choose a number for x. So we can plug in any number we want, okay? So let's try this. I'm going to plug in 0 because 0 is simple. So let's do that math. 2 times 0 squared minus 2 times 0 squared. All right, so let's do this math in our head. 0 squared is 0. 2 times 0 is 0. So this whole guy turns into 0. Same thing here. 0 squared is 0. 2 times 0 is 0. So this is 0. What is 0 minus 0? And the answer is 0. So that means when I plugged in 0, it gave me 0. Okay? So let's see what happens when I plug in another number. Let's plug in 1, another simple number. 2 times 1, 2 times 1 here. So let's do this math. What's 1 squared? 1. 1 times 2 is 2. 1 squared again. 1 times 2 is 2. What's 2 minus 2? That is going to equal 0. So when I plug in 1, I got 0. Okay, let's do one more. Let's plug in the next easy number. 2. So all right, 2 to the second is 4. 4 times 2 is 8. 2 to the second is 4. 4 times 2 is 8. What's 8 minus 8? 0. So when I plug in 2, it still gives me 0. So right now, as you see this, if I plug in any number here, will it ever give me two answers? So if I plug in 100, do you think I'm going to get two separate answers for plugging in 100 based on the pattern you see here? Or what do you think my answer is going to be based on the pattern?
The same.
It's going to be the same, right? So that means this is going to be a function because when I plug in one number, it only gives me its own answer. It's the same answer, but it's its own answer. So that means this is going to be a function. Okay? And now I could write the domain. So the domain is going to be, is there any number I cannot plug in here? Does it say anything about, hey, you cannot plug in negative numbers or you cannot plug in fractions? And the answer is no. So when that happens, we call that all real numbers. That's going to be our domain. Basically saying, hey, all our inputs, all the numbers we can plug in are available. There's no restrictions. Okay? So real quick, I just want to get you used to some of the notation. I know there's watermarks in your way, and I apologize. But when we talk about all real numbers, another way to say all real numbers is with this symbol. Okay, it's with an R with an extra line going down through it. This means all real numbers. Another way to say all real numbers is with this. This looks a little funky, but you may have seen it before. Okay, that's another way to say all real numbers. All right, so I wanted to mention this because we're going to be using this version a lot. Not necessarily this symbol, but I want to show you all of them. Okay, another way to say all real numbers, all right, let me put it underneath here, is you'll see this. It's very similar to the one I just did. That means my inputs, okay, my x's, can go from any number to negative infinity and to any number to positive infinity. So I can plug in any number between negative infinity and positive infinity. Okay, that's how that was written. That means all real numbers. All right. So I wanted to mention those. My range. So my range is very simple. We have one output, if you notice. That one output is 0. Okay. So that's pretty much the assignment you have today.